All right, section 7.3, right? We've been looking at equations and different ways to solve equations. In 7.3, we're going to introduce the concept of inequality. Um, right, when we solve an equation with an equal sign, we either get one value, right? X equals this number. Or we looked at special cases where we had no solution or we had that all numbers worked when they were identical to each other. With an inequality, it's not just one value that works. All right. So, our learning targets for today, we're going to introduce the concept of writing inequalities, and then we're going to graph them on a number line. So, a key term for today is the inequality, meaning a statement containing the less than or greater than symbol, right? And we use it to compare values, right? I can say that 7 is greater than 5. Um, Another way to say that is 5 is less than 7, right? I can just flip everything around. Um, Notice that my sign still is opening to the 7 because that's bigger, but I read this as 7 is greater than 5, or, right, 5 is less than 7. Right? Similar to, like, if I have a statement where x equals 3, I could say 3 equals x, right? When you flip an equal sign, it's still an equal sign. However, when you flip the inequality, it goes from greater than to reading less than, right? So here it's read 7 greater than, here it's read 5 less than, right? If I read it in reverse, this is still saying 7 greater than 5 because the opening means that this number is greater. But typically we read those from left to right. So this would be 5 is less than 7. Now, introducing variables to that. So right here, x greater than 2. Okay. So x greater than 2. There's not just one value that I could plug in for x, right? Meaning 3 is greater than 2, right? 4 is greater than 2. 5 is greater than 2. So we're going to look at, if I had a number line, and here's 0, here's 1, here's 2, here's 3, right? And then this way would be -1, -2, and so on. So here, this is saying that x is greater than 2. So that would mean that all of these values over here, right, including 4, 5, dot, 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 keep going on, all of the values to the right of 2 are greater than it. So we'll look at graphing those in this chapter as well. So the concepts, right? We have greater than and less than, right? Some other ways to say that is more than, exceeds. And then we have this symbol here, which is a combination of the inequality and an equal sign. So right here, it's read is greater than or equal to. Okay, so let's look at the difference between the two. So if I have x is greater than 2, okay, that starts with anything bigger than 2. So like 2.1 is bigger than 2, 2.2, 5 is bigger than 2, and so on. It does not include 2, meaning if I plug a 2 in there for x, that's not true. 2 is not greater than 2, right? They're the same. However, x greater than or equal to 2, 2 would be a true statement, right? Because it's or equal to. It has to be one or the other. It can be equal to it or bigger. So 2 and anything bigger would work in this case. So it's just adding the or equal to, where that number could be a solution. Here it's not, here it is. And we'll look at how to graph those and what's the difference between those as well. So let's start with just writing inequalities. So it says write an inequality for each sentence. It says your age is less than 6. So my age, right, is less than 6. Okay, so give me a value. Could I put 6 in here? You say no. Okay. Could I put 5.5 in there? Yep, 5.5 is less than 6. 3 is less than 6, right? So any of those values, that's all I know is it's less than 6. Your height is greater than 40 inches. So your height is greater than 40. Your speed is less than or equal, right? So I have that little line underneath, 35 miles per hour, right? And the difference is with the or equal to, like here, 6 does not work because it's not less than 6. However, 35 works here, right? 35 is less than or equal to. It is equal to, so that includes there. So this could be 35, this could be 34, this could be 33, anything below 35. Your speed is greater than or equal to 55 miles per hour. So we just define a variable and then use the symbol they give us in the problem. All right, take a minute and see if you can uh, write these inequalities, right? So it's not just saying greater than, less than, it's using some different terminology, but see if you can write the inequalities associated with numbers 1 through 4. All right, let's see how you did. So it says the fat count is no more than 3 grams per serving. So no more than 3. That means it could be 3, but not more than that, right? So it has to be 3 and less. So your fat has to be less than or equal to 3. Your height must be at least 48 inches to ride the roller coaster. So you have to be 48 inches or taller, right? So your height has to be greater than or equal to 48. You must be 12 or under to order from the kids menu. So 12 and under. So your age has to be less than or equal to 12 in order to order from the kids menu. You must have no less than, right? So no, you could have 50, but not less than that. So it has to be greater than or equal to 50 subscribers on YouTube to be famous. And I don't know if you guys are still watching that, but I'm at 48. I'm getting there, getting close. All right, determine the truth of an inequality, right? So is a certain, right, we talked about at the beginning that it's not just one value with an inequality, right? If I have that s is less than 5, or let's just say s is less than 15, whatever the case may be, 14 is less than, 13 is less than, 12 is less. So there's a lot of values that are less than 15. It's not just one single value. So in these ones, it's asking, if I plug in when s is equal to 14 in this case, does it create a true statement? So it's asking, is 14 minus 7 less than 5? So it's asking, is 7 less than 5? Okay, that's false. That's not a true statement. So this is not a solution to this here. When a is 10, so is 12 greater than or equal to 10 plus 2? Is 12 greater than or equal to 12? Yep, it's equal to, so that works. That is true. Is 32 greater than 8 times 4? Is 32 greater than 32? And the answer is no. It's equal to, but this doesn't have the or equal to, so that's not an option. It has to be strictly greater than. So that is false. All right, two ways to say it, right? So here I can read that as a is greater than, all right, that's this first one here. And the second one is saying 5 is less than a. All right, these are equivalent statements here, right? When I reverse the whole thing, it's saying the same thing. And the reason I say that is when we graph, we want the variable first. It's easier to graph. It doesn't matter, right? As long as you can say it and you understand it. But it's easier when the variable comes first. So if I ever get a situation where 2 is greater than x, if I just flip everything, right? So here, so see how this little side is with the x and the bigger side, the opening is with the 2? Flip everything and this will help you graph when the variable is first. All right, key concept. So when we graph using less than or greater than, we use an open circle to show that it does not include that. So if I'm on the number line, right, this is red, x is less than -2. So if this is 0, this is -1, this is -2, this is -3, -4, right? This side would be 1, and so on. So I want to show this on a graph. What values work? Well, -3 is less than, it's to the left. -4 is less than, it's to the left. So what we do is my key point is at -2, but I use an open circle to show that that point's not included. However, everything, let me change colors here, everything this way, but not including the -2. Everything to the left is a solution. So that's how we graph that. Looking at this one here, or equal to, we use a closed circle to show that it does include that number. So if I make my number line here, all right, again, here's 0, 1, 2, 3, -1, -2, and so on. And we'll show a shortcut so you don't have to write all that out every time. And then here's 4. So this is saying x is greater than or equal to 3. So when I graph this, I'm going to put a solid circle. A solid circle at 3, and it's everything greater than that. So it's showing that all of these values, right, continuing all the way down there, right? That's what that arrow means. It keeps going. All of those values are greater than 3 or equal to 3 because I used a closed circle, right? Open circle meaning there's a hole there. It's not including that, but it is including everything to the left. All right, so let's look at a few of these examples, right? So when we graph a number line, right, here's all I'm going to expect that you do, right? Here's the 3, right? And you just put 1 point above it and 1 point below it, right? This is saying n is greater than 3. So if you want to do it above so you know that it's open circle, right, not including 3, and it's everything this way. So the reason we want our variable first is if variable's first, you can follow the arrow, meaning I can make this inequality. If I draw an arrow with that, it points me in the right direction, right? So if I look at the next one, so 5 is my key point, right? 6 is a point above it, 4 is a point below it, and I'm going to go closed circle because it's or equal to, so it's including this. And then if I make this into an arrow, right, it points me in the correct direction. But that's only when the variable's first, right? This is saying p is less than 5. So it has to be to the left, smaller than 5. Okay, now notice in 3 and 4, I put in italics just to kind of show it that the variable's not first. So I can't use this as an arrow. So I have some options. I either flip it and put the variable first, right? So notice how it's pointing at the x. So when I do that, right, 7's to the opening. So now I can graph that, right? And we'll go 6, 7, 8, right? And notice as 9, 10 this way and then 5, 4 this way, but we only see a small picture. And it's going to be an open circle at 7, and my arrow points to the left, right? When the variable's first, that arrow points you in the right direction. So here, z, right, I have to flip that around. All right, I gotta be careful here. So here's -3, -2 is this way, -4 is this way. And it's going to be a closed circle at -3, right? Variable first in this one, so I can follow that arrow, right? The z is less than or equal to -3. So -4, -5, these are getting smaller going to the left. All right, so next one is going in reverse. So taking a graph and seeing if you can write what inequality that represents. So for example, Let's go -4, -3, -2, -1, 0. So here's my graph. All right, we're going to go here and this way. All right, so we just define a variable, let's say x, okay? And it's an open circle, so I know I'm going to use this or this, right? And if I look at my arrow, my variable's first, so if I look at the arrow, it's pointing this way, so I know that it's got to be greater than, right? These values are getting bigger, and the key point there is -4. All right, so let's see if you can figure out what this one is. So let's say here's 9, 10, 11, 12. All right, let's go here and this way. See if you can write that inequality, right? It doesn't matter what variable, you can use x. Okay, write the inequality that's associated with that graph. All right, just a reminder, with the closed circle, you're going greater than or equal to, less than or equal to. Right? And we should notice that the variables first in my writing, 11's the key point. These values are all less than, right? And I can see that this arrow is pointing left. So that's what my inequality should look like. All right, try the following problem starting on page 343, right? Separate sheet of paper. Do these problems and then check your work using the answer key. All right, you have questions, let me know. I hope everyone has a great day, and we'll talk to you soon.